Mount Pinatubo, which erupted, I think it was
92.
what was it?
1992.
1992. When you look at the thank you. When you look at this, glad somebody knew what was going on here.
So I did close by.
When you look at the satellite record, you can actually see the aerosols that were actually pumped into the atmosphere because of Mount Pinatubo had a cooling effect globally. So yes, now in terms of a long trend in climate, that's still debatable. But in terms of something that lasts, Mount Pinatubo was actually amazing. The effect lasted well over a year. You can actually look at the satellite records, and it had a dramatic effect in terms of because of all the aerosols that were pumped into the atmosphere. Chichona was another one.
One of the first slides after Al Gore, you showed the temperature change over for the several thousand years. It was in centigrade. How many degrees was the actual change over the last 10,000 years?
Oh, I think from the hockey stick plot, let's see. You're talking about probably, between 1 and 2 degrees, which is what the estimate is right now. They're looking at, now, that brings up a good point, Jim, again, in terms of separating fact from fiction. There was a talk at the American Geophysical Union meeting in San Francisco. Yes, I mean, where are the discrepancies in these models found? One of the areas is, in fact, in looking at the rate of change. There's still a lot of science that needs to go into that. We know that things are warming up. We know that the sea level is rising. However, do we know with a complete amount of certainty how much that will rise over the next 100 years? No. Do we know how much temperature will rise with complete amount of certainty over the next 100 years? No. But as my cousin in Miami asked me when I was down there for a meeting, I don't know if it was half a joke and half serious. I don't know. Maybe it was more serious. She said, "Jorge, you are going to tell me when I have to move, don't you?" That's the next big challenge. I think, in a sense, she really hit the nail on the head. That's the next big challenge, I think, for not only for NASA, but for all agencies internationally that are involved in these kind of things. How is it going to impact us? How is it going to impact, the water supply in Southern California? I'm working with colleagues in Peru, in fact, to look at the impacts of climate change on fisheries off the coast of Peru. Whenever they have an El Nino down there, it is huge. Because the Peruvian economy is based largely on two things. One is fisheries and one is tourism. So it's huge. Anything that would have an impact on the fisheries down there in terms of, climate would have a huge impact economically. And that's one of the areas that I'm focused on, that I'm very, very interested in.
Yeah, one question about with the oceans taking in and moving so much heat, as you described it, and then you see, it looks like the hurricanes, which gather over the oceans, that's where they draw their moisture. You see things like the tornadoes that are forming out of moisture right now, beating up our friends in Oklahoma. How do the oceans impact something that would hit inland like Oklahoma? Because it still is one planetary ecosystem.
Yeah, that's a great question. That's a great question. And, well, let me just ask, why do we have, and that's another question in terms of understanding extreme events in the future. Obviously, that's a huge research issue now. Why do we have tornadoes and Tornado Alley? What are the weather conditions that make that particular area of our country so prone to tornadoes? I mean, there's nothing like this happens anywhere else in the world. Well, I mean, they have tornadoes, but nothing to the extent of what we see in our own country. Why? What are the meteorological conditions that make Tornado Alley so unique? Yeah.
Well, actually, I had a question. I've been holding my hand up, but not the answer
Oh,
to your
okay.
question.
Okay. Well, part of it goes back to to Mel, to what you're saying. You have warm, moist air from the Gulf of Mexico collides with dry, cold air from Canada. When those two air masses collide, something's got to happen. And that happens to be right in the center part of this country. And what happens is you have severe thunderstorms, which is exactly what the meteorological conditions you need for tornadoes. So the question becomes, if the planet is warming up, and in fact you do see, and some people were looking at this, why has this year been so tragic and so devastating? In fact, you're seeing more moisture coming off of the Gulf of Mexico this year than you've seen in the past. Is that something that meteorologically is causing the kind of devastation that we've seen in Oklahoma? Now, don't go away with this saying that I'm saying that the tornadoes in Oklahoma were caused by global warming. No, you can't say that with any amount of statistical certainty. But is it something to seriously give thought to? Yeah, you bet. And people are doing a lot of research on that right now. People are looking at the total number of extreme events that have been happening and asking that question. Is something going on? Yeah.
Is there a trend between warming and the change of polarity? Change of polarity, because our Earth changes.
Oh, no. Yeah, those are two, well, as far as we know, those are two separate. I mean, the natural cycle in the Earth's climate is basically caused by two things. There's a natural cycle in the sun itself that the sun goes through. There's also a wobbling. Our Earth is like a top. It wobbles. Okay? It's not always, it doesn't always stay in the same, direction. Well, that wobbling also causes a natural cycle. Those are the dominant driving forces behind the natural variability of climate that we see on our own planet.
I forgot how many percent is the Earth's surface of water. I mean, how many percent does Earth contains on water?
Yeah, 75%.
So it's greater.
Yeah.
But is it the water cycle? How will it be changed concerning global warming? Because the Earth rotates around the sun, and there are times of the year when it's closer to the sun or farther away from the sun. Is that not a factor that JPL would look into rather than global warming as a cause of rise of carbon dioxide and rise of sea level and all these other topics that you mentioned?
The what? I'm sorry. Could you?
Does not the closeness of the Earth to the sun, because there's gravity involved in that, right? As it rotates
Yeah,
around
but
the sun.
remember, the seasons on our own planet is not caused by, is not caused by the Earth being further away from the sun. That's not what causes even the seasonal changes on our own planet. The change in seasons on our planet, which is the strongest climate change we have, is actually caused by the tilt of the Earth's axis.
Right, it's rotation, 30
Yes.
degrees from the
Yes.
vertical point.
There's very little change in the climate due to the fact that, the Earth's orbit is not perfectly circular around the sun. It is elliptical, but that has very little effect. The main driving mechanism, even in the seasonal changes, is the tilt of the Earth's axis. Now you know more. They asked that question to students at Harvard, physics students, and they said the same. Hey, it's the fact that the Earth's orbit isn't circular, but that's not true. It's the fact of the tilt of the Earth's axis. If the axis of the Earth was straight up and down, we'd have one season.
You should have asked at Yale. Go ahead.
Yeah.
Well, the Earth has also gone through many ice ages and warm-ups and ice ages and warm-ups. Where are we at in that?
We're right now, and that's why, the natural cycle is that we should be warming up. We are coming out of an ice age since about 5,000 years ago. We're in what they call post-glacial ice, period. So we should be warming up. But, again, the question is not, can we as human beings change change. I think it's not an issue of whether we can change the natural cycle to where we're causing it to cool down, but it is the issue, are we accelerating things? Are we making things go faster than they normally would?
Jorge,
Yeah,
back in the 70s and the 80s, we heard a lot about the ozone layer
yeah.
depleting over Antarctica, and I don't recall hearing anything about that in recent memory. Is there a reason for that?
Yeah, actually, that's a great example, Matt. In fact, you know, I always use that as an example of, well, if nations can get together and, you know, they can solve problems on a, you know, planetary scale, so to speak. And that's an example where the banning of chlorofluorhydrocarbons, in fact, has had an effect. The ozone hole, in a sense, has shrunk. And there was, you know, but that was also different. You know, there was a very clear, you know, and I'm one of the ones that says, well, the problem was with global warming, there's more of an impact economically, you know, in terms of it's more complicated than just banning one particular thing. But that's an example where, again, if people say, well, you know, human beings can't have an effect, well, that's an example where absolutely human beings did have an effect, and they actually solved the problem. It's the same thing with you know, smog in Los Angeles. You know, what was it? I came to LA 30 years ago, and I remember that you turn on the radio and they say, you know, if you have to breathe, stay indoors. You know, it's stage 2, stage 3 smog.
Believe what I used to breathe when I was a kid growing up here.
Yeah. And then, but now, I mean, we don't. I can't remember. I mean, we haven't even had a stage 1 smog alert, have we? So what's changed?
Gasoline.
Yeah. We made a conscious decision. We as Californians would pay more money to have better air. You can argue that, but we made a conscious decision that that's what we want to do.
You mentioned that the salinity of the oceans are changing. How's that going to affect the sea life?
Well, yeah, the factor of salinity changes is because the salinity is for example, if the Earth's water cycle is speeding up, you're going to have more evaporation. More water is going to go into the atmosphere. That would increase the salinity of the oceans because you're extracting water, but salt stays behind. So if you see an increase in salinity in the oceans, then over time, then you know it's going to have an impact on the water cycle. But in terms of ocean life itself, that's actually a minor issue compared to other things they're looking at. For example, the acidification issue, which happens because carbon dioxide, once it goes into the ocean, it turns into carbonic acid. So it causes the pH actually, because of the oceans, they get more acidic. Is that going to have an effect on marine life? So all of these questions are huge areas of research right now.
When you mention about cycle, are you referring just the water cycle? Because from the academic standpoint, you have nitrogen cycle, you have carbon dioxide cycle, you have sulfur cycle. Are you just referring specifically on the water cycle?
Well, the water cycle is the one that is affected by global warming. You know, that's the one that has the most immediate. And then there's the feedback. The water is also a greenhouse gas.